In this lesson, we'll talk about lists with Python. Now, we've seen lists before in previous lessons. Python lists are an ordered collection of elements. They're ordered in the sense they have an ordering. Something is first, something is second, something is last, and each thing in the list is called an element. So let's take a look at some examples. Here are two lists within the Python interpreter. Notice we use the square brackets to create the list. The first list has 4 elements, each is of type number. The next list has 3 elements, each is a string. Note that we use comma to separate out the elements in the list. Now, the elements of the list do not need to have the same type. Here we have a list made up of numbers and floats and strings and booleans and even expressions. Lists can also be nested in the sense that they can contain other lists within them, right? So in the example here, the third element is itself a list or a sublist. Lists can be empty with no elements, in which case you have square brackets with nothing inside them. Assignments also work on lists. So you can store lists in variables, as we have done here. We have products, prices, quantities, and coupons. And then we use these variables to create another list. And if you print above, you will see that it is a list made up of other lists. Now recall with strings, we had a function called len that would give us the number of characters in that string. Similarly here, len gives us the number of elements in the list. So if we were to print len for each of the variables above, it would give us the following values. It would show that products had 3 elements, prices 3, quantities 3, coupons 0 because it was an empty list up here, and transaction has 4 elements. And this is because len counts the top level elements. Now also, as with strings, we can use the square brackets to index into the list. The expression within the brackets determines which element is returned. So let's consider this particular list. It contains a bunch of numbers. There are 6 numbers in them. If you index the 0th element, this will give you the first element in the list. And if you index len nums minus 1, this will give you the last element in the list. Let's take another example. Nums 2 will give you the third element because indices start with 0, so it'll be 0, 1, and 2, and that's why it returns the -2. Num 9 minus 5, which gives you 4, will give us 0, 1, 2, 3, 4, which is the -25. Now, what would happen if we tried num minus 2? Interestingly enough, it gives us -25. And this is because it counts from the end of the list. So nums minus 1 is the last element, and then this is nums minus 2 is the second to last element. So nums minus 1, again, is another way to get the last element from this list. Now, what would nums indexing len nums, which is nums 6, what would that give you? Because that would be one beyond the end of the list. Interestingly enough, this gives you an error condition, which is an index error, list index out of range, which is a very similar error that you might get with strings if you index beyond the end of the string. A very expected error here. Now, recall from earlier, we had this transaction list, which was made up of other lists. How would you index into it? How would you, suppose, get to the list of quantities? Now, this is the sublist right here. Or how would you index further and get to bread string here? Now, quantities is available to us at index 0, 1, 2. So that would just be transaction 2. For bread, we must first get to the first element and then further index into it. So this is transaction 0 right here. And then after that, we get to 0, 1. That is why you have two different indices here. The first one is 0 to get to the first sublist, and then it's 1 here to get to the second element of the sublist. So that's what's happening there. Now we have two new Boolean operators available to us to test membership with lists, and these are in and not in. Now they're Boolean operators, so they always return true or false. So let's try to use them. Now here you have our original transaction list, and if we index into it, transaction 0 gives us the list of products, and then we can say apples in transaction 0, and since apple string does exist here, it returns true, while pears does not. We can try out not in. Beans also does not, so that returns true. And then apples in transaction returns false, because transaction is the top level list and apples is not an element of it. There are other list operations available to us. Now with strings, you may have discovered that you can use the plus operator to concatenate strings. So if you had down plus town, and that'll give us the concatenated string downtown. You can do the same thing to concatenate two different lists using the plus operator. In this case, if you had a list 1, 2, and you concatenate with 3, 4, and then you get the bigger list stored in L. Extending the meaning of an operator to other areas. For example, plus is used in numbers or floats to add them. Here, for strings and with lists, it is used to concatenate. This is called overloading the meaning of an operator. So overloading is a new term I would like you to remember. Let's go further and try out another example. You can take L, which contained 1, 2, 3, 4, and then you can create a list out of S, which contained downtown, to get a new list. Another operator that has been overloaded is the asterisk or the multiplication operator that we knew about from math earlier. This allows you to create repetition in lists. So if you took the list containing the number 1 and you said asterisk 4, it basically repeats it 4 times. If you took the list L here, which is 1, 2, 3, 4 earlier, and you said asterisk 2, it will repeat it twice. Or if you took a combination list earlier, including downtown, it'll repeat the whole thing twice here. Another concept with lists is slices. We can take parts of the list. So the expression list m:(n) gives you part of a list. It gives you the sublist or a slice of the list starting at index m and ending at index n-1. So let's take this example. Here we have a list X, which contains the characters from A through G. Now, if we said x1:3, this should give us a sublist starting at index 1 and ending at index 2, which is 3 minus 1. So 1 here is 0, 1, B, and it ends at 2, which is C. So it gives you a sublist with B and C, which is what you see here. Now the values of m and n default to something. So if you don't provide an m, it defaults to the beginning of the list, which is index 0. And if you don't provide an n, it defaults to the end of the list, which is len list -1. So let's try that out. So in this case, we are saying from the beginning of the list going up to the 3 minus 1, which is the second element. So 0, 1, 2 here. In this case, you start at index 4 and go to the end of the list. So 0, 1, 2, 3, 4, which is E to the end of the list. That's what you see here. And not providing anything will just gives you the whole list. Now lists are modifiable. You can change parts of the list using the assignment operator. So here I have another list Y, which contains apple, pear, and grape. And if I say Y index 1 equal to cherry, it'll take the pear element and replace it with cherry, and that is what you will get. Lists are changeable, so we say they're mutable. Strings, by contrast, are immutable. Strings can't be changed. You might think you're changing a string by using the assignment operator, but a copy is getting created. Lists are changeable, mutable. Strings are not. They are immutable. We can use slices in assignments. So let's take a look at that. Recall we had our variable x that contained this list. If you assign new values to the slice 1, 3, so this will be going from index 1 to index 3 minus 1, which is 2, and you're assigning this, it'll basically take BC and replace it with XY, and that is what you see here. The size of the slice does not need to match the number of elements that you're updating. So for example, here you are replacing two elements, index 1 and index 2, with with a list of 4 elements. So in this case, the XY is getting replaced by -1 4 times. So they do not need to match. In fact, you can use the same usage to delete part of the list or some of the elements, or squeeze in new elements in the middle. So here's an example. I am taking this particular size and setting it to the empty list, which basically means that this portion right here is getting deleted and it is the remaining part of the list. Or you can say in this location, the first index 1, I am squeezing in 2 new elements. So right after A, it's putting in hey there, and then it's the remaining part of the list. Now, this usage is a bit confusing. It is easier to use the del operator to delete portions of the list. So you can say del x index 1. So in this case, it's taking the hey and deleting it, and you have the rest of the list. Or you can delete a slice saying from index 2 to index 4 minus 1, which is 3. So here, 0, 1, 2, 3, so it's going to get rid of the -1 and -1 here. Now here's a question for you. What would happen if you delete an element that is well beyond the range of the list, or you delete a slice that extends well beyond the range? So let's actually try this out. We can copy this and we can try it out in an interpreter. So suppose I have X, I'm going to store the list that's mentioned there, right? And let's try the first thing, del X 100. Now 100 is well beyond the range. What happens? You get a runtime error, which kind of makes sense. Index list assignment index out of range. That makes sense. Now let's try out the second one, which is del X. Now here we're starting at index 2 and going well beyond the list. So this in fact does not give you an error. There is no runtime error here, but the question is what happened to your list? Let's check it out. And in this case it did, even though the second value was well beyond the range, it did go and delete the rest of the list starting at index 2. So you got no runtime error there. The next two concepts I want to talk about is aliasing and cloning. There is a function that we are given by Python called ID. This gives back a unique ID for each object. So what does it all mean? Let's take an example. Here I'm creating a list of, and assigning it to a variable n, which contains 1, 2, 3. And then I'm similarly creating another variable with a list of the same values. Now, if I call ID on n, it gives me back a number, and I call ID on m, it gives me back a different number. So although while n and m have the same list values or elements, they are very different objects. They're different copies, right? They are not pointing to the same location in memory. In fact, we have an operator called is that tells us this, whether two different variables point to the same object. So while n is equal to m, they have the same values. The lists look identical. That is true. N is m is false. That is not true. In fact, you can say n is not. That's another operator that is available to us with the expected meaning. If we said n is not m, that would be true. Now, interestingly enough, the assignment operator, the equal to sign, actually will create an alias. It'll create two variables that point to the same object. So let's take an example. This is very interesting. Recall we had n, which has 1, 2, 3. Now if we were to say m is equal to n, and now we check are n and m pointing to the same location in memory, you will get true. A new copy has not been created. A variable m has been created and it's pointing to the same location in memory as n is pointing to. And you can test this by modifying one of the elements. So we took the second element here and put a dash in there. Look at m, it has a dash as well. So these are actually two variables are pointing to the same location in memory. That's why if you change one, you are changing the other. Now, suppose you did want to make a copy. How would you do that? A copy or a clone can be created using a slice operator. So what does that mean? So if instead of doing m is equal to n, if we did m is equal to n, and in brackets we had a colon, now this creates a whole new copy. And if we tested this with the is operator, it will show that now indeed n and m are two different objects. If you modify one, it will not change the value of the other. Now the last concept I want to talk about are a series of functions that are very useful that are available to us for lists. And you can get to them using this dot operator. So let's just actually use an example to make this clear. Let's create a list called Z that has a bunch of positive and negative numbers. The first function called append, so you use the dot operator, z dot append, and you pass in a value. It's basically appending that value to the end of the list. So if you see, it's the same list with the -1 appended to it. Insert gives you a little bit finer control. It allows you to insert a value at a particular location. So it puts 1000 at the second location, 0, 1, 2, and that's where it got inserted. Count gives you the number of times a particular value exists in the list. So it asks, how many times does 1 exist in the list? And there are actually two elements here that are 1, so it gives you 2. And index says, what is the index of the location where 11 first appears? So it is 0, 1, 2, 3. That's what it returns. You can reverse the list, the ordering of the list, by using reverse. So now it is the same list, but in the reverse order. You can sort a list, going from the lowest to the highest. That's what's happened here. And then you can remove an element from the list. The first occurrence of it is removed by calling remove with a value, and here the 2 is gone. Now notice that some of these, specifically append, insert, reverse, sort, and remove, do not return a value, right? So don't use it to set a variable. That has been the lesson on lists. Thank you.